everyone. I think we can slowly start. We're very happy to see you all here. It's really amazing that all the 20 teams who actually submitted their first ideas and formed teams on Friday submitted already today. But as you know, it is a competitive hackathon, so we had to choose the top ones already and the ones who will be presenting today in the final presentations and final pitches to the jury. So today, welcome you all here for the final presentations. I hope you are still breathing, and I know quite a lot of you have slept very little and worked very, very hard to make it to this point with all the ideas and the work that you put in your ideas. So without further ado, I'm going to go through a couple of things that you need to know before we actually get to the pitches. Sorry. Just a reminder on the challenges. So we had 3 challenges, and we also encouraged you to, during your presentations, mention the challenge that you're submitting it under. The key thing is to kind of understand of how your idea and how your prototype or whatever you have built throughout these 2 days, 3 days almost, how does it go under these themes? You can vaguely mention it. It can be very clearly mentioned in your presentation. It's kind of up to you. But in case it's not added to your presentation, just please keep a note of that, please mention it during your presentation. So how does it apply to one of these challenges? So equipment and mobility, communication radio technologies, and the third one was energy for defense. So just keep a note of that. A reminder to everyone of how it's going to work. So you have 5 minutes to pitch. It will be strictly timed. So I will be here sitting in the front, timing your 5 minutes. When you will have 1 minute left, I'll give you this sign so you know that you have 1 minute left. When the time is out, I'll show you this sign. I'll leave it for you to just finish your sentence. But once you finish your sentence, we'll come to the stage and basically interrupt you if you keep on presenting and talking. Unfortunately, I'm really sorry, but we really just have the 5 minutes for you. And then we'll have also at times 2 minutes for the jury's questions. The jury is sitting here. I'll introduce them in a second, but just a note of that, a reminder for everyone of how it's going to work. When you come to the stage, only one person is encouraged to come to the stage. You just have this area, so we encourage you to remain in this area where you can see in here so that you can present it. This is so that we can see your presentation in the live stream, and we can see the person not going out of the screen when you're presenting. That is just because of this. So we really kindly ask you to try at least keep in this small square that you have in here. One person is presenting, but if you have another teammate that you wanted to ask on the stage to help with answering questions, we encourage that teammate to then be sitting fairly close to here so that you don't spend those 2 minutes of time when that teammate is coming to the stage. That will be time that you lose, basically. So I invite also that teammate very close to here, and when there's a question that they need to answer, also please come to the stage and answer it. Also, a key note about your presentations and pitches. Firstly, in order to switch the slides, use this, this clicker. It has a button to the right. That means that you're switching to the front. It has a button to the left, and an arrow to the left. That means you're switching to the back. Also, very important information. Anything else that we wanted to mention as well is about the presentations. Please keep the microphone where it is just a reminder that it helps us to make sure that we hear you, and it's there in the space. All right, so judging criteria, you saw this in the guidelines, you saw it in DevPost, a reminder of how the judges will evaluate your presentations and your pitches and your prototypes. They have a link to your DevPost submissions. They have a link to what you described about your idea in case you added any prototypes, anything technical that you did, links to your code repos or something like that. They have the access to it because they have your DevPost submissions. But just a reminder, firstly, relevance to the chosen challenge. So keep in mind, please mention how this generally fits into the challenges and in the defense tech team, ideas overall and theme overall. Idea and originality. team progress. So what have you done? This is something that we kind of reminded you again and again. Please share what you did during these 48 hours. Otherwise, it's very unclear to understand all the work that you put in your ideas. So be explicit in it. Don't be shy on sharing, yeah, this is what we did. Because I know that all of you did quite a lot. We saw it. So please do share it. Impact and implementation potential, and then the final one, presentation quality and communication. So I know there's a couple of specific teams that know who's presenting because they're better at presenting. All right, then introducing the jury. So Carlos Berzinch, and give a round of applause to him. You already saw him yesterday. Thank you, Carlos, and thank you really for your presentation yesterday. I think a lot of people got involved into this discussion with you. Gunita Deksne, Director of Innovation and Acceleration Center, University of Latvia. Mara Ubele, Senior Expert, Innovation and Research Policy Section, Defense Industry and Innovations Policy Department, Ministry of Defense of the Republic of Latvia. Mara. And Anders Zeltinch, Lead Mechanical Engineer at Original Robotics. All right, so now that everyone knows what's going on, this is the sequence. This is what we shared in Slack, so you should all know the sequence, how it's going to happen. We're going to have a presentation after presentation, so if you're paying attention, you can also use the Slack messages that we have about the sequence of the presentations. So keep this in mind. You can also find it on Slack. The jury also have the sequence in their files, so everyone should know about it, and your presentations will follow one after the other. So in case you see the other presentation and the presenters kind of finishing off, please make sure that you're kind of prepared to go on stage already and do your presentation next. So follow along and pay attention to the sequence. All right, so I think without further ado, I'm inviting to the stage firstly Martin, who will start doing the pitches, and he will be the one managing all the pitches and managing the jury and the jury questions. I'll be the one who will be strictly timing you to make sure that we fit in the same criteria for everyone else. Martin?
Okay, awesome to see all you here. You know, 20 teams started, 20 teams submitted things. And so, yeah, I welcome to the stage the first team with the idea UAV threat detection. Okay.
Hello, everyone. This is Team 1, and this is our idea. So it's basically all started with when we were in Estonia Hackathon, we spoke with some soldiers, and they told us about a very critical point they face in the war zone, which is the attack of the low-attitude suicide Russian drone. And this video was one of the realistic danger that happens to them in the war zone, but this is PDF, it will not work. But it killed all the mobility and the car and some soldiers. So basically, our idea is to make a very simple, optimized systems which can be built on literally anything. And this system should be efficiently, simple, and optimized. So our system is based on combining of some sensors, metallic, thermal, microphone, leader camera, and RGB camera. We collect these sensors, we collect all the data from it, we analyze the data, and we train a machine learning model of 95% accuracy of detection. So our system can be built on literally anything, aerial machines, grounded machine, military equipments. You can build it on literally anything. It's simple, easy to implement. So why our system? Firstly, this idea is the backbone of the aerial defense sector. If this idea succeeds, we will open a very wide door of creative idea and implementation of the aerial defense sector, and it solves a real critical danger in the war zone. It's already existed concept, but the existent one is very complex and not optimized and efficient. So that's what we solve in this idea. And it's very efficient. It assures that 90% accuracy detection. So how we can build this system? Firstly, we made a very great process in building a specific simulation environment for the Baltic area's war zones. So, and then we simulate our situations in this simulation environment. And we collect the data, we train our machine learning model, and then we put the model in the simulation again and see a very great success in saving the soldiers and saving the mobility. And after that, we will do the prototyping and then testing, but we didn't make it yet. So our system, it's compared to the defense sector equipment, it's very cheap. It's range between 1,000 to 1,200 US dollars, and with the big amount of manufacturing, it will go very more or less than this. So, and this is our market plan for the project. And lastly, this project is very strong and very efficient for the air defense sector area. If this project success, we will save big amount of mobility, soldiers, and we will open very creative idea to apply on this sector. And thank you.
Okay, now it's the time for jury's questions.
Hey, how would you transmit the data that you receive from the sensors?
I'm sorry?
How would you transmit the data you gather from the sensors?
Transmit the data?
Yeah. Because if you know that something is like flying nearby, like you need to inform the person.
Oh yeah, how to inform the person. This is a good idea. This is, as I said, it's very open, wide range. We can, our idea is to, more implementation is to make automated gunfire, which is can fire on the drone by itself, because we detect 400-meter drone when it's coming 400 meters far, and it's like 7.2 seconds. So we send alert to the soldiers, and there is an automated gunfire. So this gun can just take it down by itself, or alert the soldiers, and soldiers can do what the protocol says in this situation. He's my teammate, he can.
Yeah, we are talking about one standalone system that maybe not multiple devices to connect with each other. It is open for this, but to secure from the jamming risk, it can work itself as well. In the future, we plan to attach it some shooting mechanism that it can gather data within sensors, and within itself it can determine and track the target and hit the target. But it is open to communicate. Since our main focus is mobility security, we didn't focus so much on the communication, but it's open that we can do it with multiple devices that they can work together.
Okay, thank you.
Okay. No questions.
Okay, sadly, we have run out of time for questions. But big thank you for this team. The first team is always the hardest. Okay, and now I welcome the next team with the idea. 1 second. The idea is a beacon snap band. Big applause.
All right, hello everyone. We are Team Metrinch, and today we will be pitching our idea, a beacon snap band. That's the wrong button. So the problem we choose to tackle in this hackathon is that in civilian areas that are urban, when an attack happens, people might get buried under rubble. They are very hard to find. The time to find them is very critical in ensuring that they get the attention they need, and the resources used if multiple attacks are happening at once can be very extensive, and it's a very topical issue. As we can see, there are also some statistics from Ukraine, unfortunately. So what we set out to do in this hackathon is, with our background in electronics and IT, create a easy-to-use, reliable, a durable, and a low-cost solution, the Beacon Snap Band. How it would work? Like, if you have this product in your home, which you would receive at your nearest either shelter or a government area, if you hear an air raid siren or you get a notification on your phone that an attack has begun, all you need to do is react and snap it on your hand just like you would with a reflective one. and you would be in a snapband mesh. When emergency services arrive to this location and you are buried somewhere under there, they would have anchors that, by listening to the signal the band emits in the close range, would pinpoint your location under that rubble. This could also be expanded to not use manpower by attaching the beacon to a drone, or even a rescue dog, which we also see used in some other areas where accidents are prone to happen. It also comes equipped with a long-range transmitter for the mesh. Let's say this is a pile of rubble and there is a person in critical condition under it. The band detects that this person needs the most help, but the close-range signal just can't get through it. So it just finds the nearest person with the band in your building and creates a mesh. And via algorithm, the person who is most likely to get the signal through to emergency services pings the amount of people around him, the amount of people in a critical condition, and thus emergency services know the status of this location. And when they get to the site, they can choose how to operate based on the long-range information. Yeah. So what's in the band? It has the two transmitters, the far side one and the close range one. Two sensors for monitoring life signs, such as a heartbeat sensor and a temperature sensor. Of course, the brains as a microcontroller unit, and a protective case for the battery. By our calculations, these components could last multiple days. As we know, 3 days under the rubble could be enough to kill you, unfortunately, even if your health is not at risk immediately. Have we seen this before? Well, in areas of high danger, yes, we also see some similar implementations, such as Pyro Guardian for locating people during firefighting, reflective bands in jackets, and a NASA finder which uses microwaves to listen for heartbeats and breathing sounds in rubble. Can we expand this further? We definitely think we can in areas with earthquakes, tsunamis, and such. Applying this for marine forces by adding additional sensors and building on existing protocols such as the dogs or drones. We could also gain a monetary value from this by selling it to companies that operate in these high danger areas or are, affiliated with rescue. Our team, we are 5 students, 4 from Riga Technical University, 1 from Latvian University. We came into this hackathon not knowing which idea we would tackle yet. And during the hackathon, using the resources we had on hand, we actually modeled a wristband, and by measuring the Bluetooth signal from it, charted out a map with some decimeter accuracy in a cluttered table environment. Of course, we would need to build upon it further. So, in summary, how this idea would work is that the time to rescue would be reduced by giving information to emergency services, automating with drones the anchor placement, and saving resources for teams that just do not know where they need to go and when. That will be all. Thank you.
Okay, now it's time for jury questions. 2 minutes.
Okay, thank you. What's the difference between senior monitors and the other available monitors in the market?
Sorry, what monitors?
For example, senior, all people monitors. They have this kind of bands to detect problems.
Yeah, they listen for vital signs, but they are also connected to a network that might be under attack, such as public infrastructure. You can ask the same question, like, why not just use a phone and an app? And this band would also be encrypted, such as the data is also algorithmized and for threat detection. If an old person goes into shock and you need to send it, you mostly know where he is, where to find them, how and why, and you need that public information. We create a mesh with one person sending out information about multiple people so that it doesn't create a hot zone if this data gets intercepted.
I have a quick question. Have you thought which, let's say, part of the public actually will be your end users? The companies or the persons?
For the defense side, it would definitely be just civilians. Our product would be aimed to be low cost. The sum total of the parts would be around 12 euros. So for defense, it would be an investment to hand out to people, and that's the benefit, for the people.
So you advise for me to buy your product, me as a person. If I feel threatened, then I need to buy.
Well, depending on your situation, but like yes, for people who maybe don't fear war but are in earthquake areas, yes, that could be a great way to keep yourself another layer of security. For war times, our ideal solution would be for these to be handed out. You don't buy them, you can go get it at your shelter, so you save resources by knowing which people to save instead of investing a lot of money in just clearing rubble.
Thank you to the second team. The time is out for your questions. And now I welcome to the stage the next team, Atlas Ray.
Thank you. Hello everyone, my name is Victor from Atlas Ray. Area intelligence for the safety mobility. It's a tough 48 hours actually was to discuss this question, how we can address this, because previously we have the experience with the pollution detection on the different area like sea, ports and everything, but how we can address it? Because the aerial mobility is not just you get it fast, you get it safer, but there is quite many invisible hazards there. First one is, of course, the mines, which is located everywhere on the roads and the side of the roads. Second is the fiber optics is waiting till you heat up when you're driving sides. And of course, the camouflage traps. Everything, what we can do with this. And we're thinking, okay, we are doing the oil pollution. Let's think how we can detect it, also these threats. First of all, we must address several questions, important one. One is they should quite operate in tough environments. So no GPS, no communication with the internet. Second is it should be cost low and should be easy to scale. And the last one, but not least, is they should use the similar platforms or the same platforms which is currently used on the real defense, like for example, the Ukrainian MOD. And we come up first is let's take the already existing systems. We remove the communication from the servers and put everything on the computer unit. We located this on the matrice 4T. Second is we attach additional multi-sensor, which we use for the data collection. We use the 3D printing mount, special one, to attach everything in one. We add one more layer on the operator layer, so it means that he will be not interrupted with the, like say, many false detection. He only will be interrupted when the system will detect something suspiciously. Okay, so what we will have it? First, it's imagine there is like driving the column on the roads. The system will operate it on the forward at least 10 minutes in advance before the crossing. And what we will get is 70% faster detection when comparing the traditional methods. Is one, and again, there is plug-and-play solution, so it means the operator don't need to do something additional like training or something like that. He just needs to put this equipment on the existing system and launch it. That's it. If the system will detect, he will pointing, hey guys, here is something wrong there. We found something. There is the camouflage. There is the hidden mine or something like that. One more important thing is we need to do some hacking on the existing system to fly on there is no GPS, so it means we hack the existing system to use the visual position sensor and avoid the drifting on the no GPS environment. It's quite easy to use, so it means that everything in one circle. The data collection go to the same way in the offline processing on the same onboard delivery to the operator, and this information can be also provided by the team members using the meshing communication. One more, if we're talking about the audience, who is of course is defense and security forces, is our first one, but of course it's not least one. We see this is when when the war will be over, we can use this system for the mining process on the, let's say, territory when was, let's say, affected by conflict. And of course, other, like say, civilian use cases is there. We done huge work, actually we're quite tired, but we done this, let's say, integration of our system on the onboard processing. Second is we do the hacking of the existing system to have the ability to use the visual positioning sensors. One more is the modularity, and let's say it's take around 10 minutes to plug and play the systems, and plug and play solution and the cost. In the end, we see it's around 3,300 to 3,500 euros per one unit. So our team is basically all from the RTU University, and we get one more let's say, colleague during the hackathon, which is great. Actually, next steps is that as all the startups, we need to raise some amount of the money, definitely, to finalize the MVP. We need to do the pilot project. We already agreed during the hackathon with the Latvian MOD to do the real test on the real polygons, collect the data, and the scale for dual-use markets. Definitely this. Atlas Ray, we protect what is matters. Thank you.
Okay, big thanks. Now it's time for jury questions.
Many questions.
Yeah. Can you please elaborate a bit more what technology you use for the detection of the mines?
Okay, so there is like UAV occupied, let's say, I will explain the sensors. So one is on the system itself, it's a thermal camera, RGB camera. Second is we use multispectral camera with 5 bands, and one more is near band is there. So everything is like we need to do the, like say, online streaming to the manifold, or like say CPU data, and after do the processing using the algorithms.
So basically, you gather the data. Okay, you gather the data on the drone, then you get it back to the field.
No. It will be processed on the drone itself.
Edge processing.
Yep.
Okay. Do you have some kind of indicative ideas of the false positives, false negatives?
Definitely, we need. Actually, I can explain on my currently experience. We currently achieve in this moment around from 60 to 70% of the accuracy of detection, but it definitely can be improved when we get the more data from the real polygons. We need to train a little bit more the AI machine. So this is ongoing, and I hope when we will have the real data, it will be even better. Yes, I see many other questions there.
How much the module weighs, and how does it impact the flight time of the drone?
Definitely it will impact, but the good thing, so yeah, first of all, how much. The module itself, the camera plus the processing unit will around from, let's say, 400 grams to 500 grams, which is okay. It will affect the flight time. We expect from 10 to 50% of the affected, let's say, flight time. But again, this is something like modular system. So it means when you don't need it, you take it out. If you really don't, like say, planning to do the mining detection or this threats detection, when you need it, you plug it in, again, 10 minutes, ready to go. What I would like to highlight it, there is no, let's say, interrupted by operator. There is no additional training is required. He just need to float, and if it detected, it will be a ring, 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 ring. There is something, and pointing on the specific area where he's just pass it. So when it would show it. And after that, he can share this information with his colleagues and do some troubleshooting in this case.
Okay, thanks.
Yeah. Thanks to this team. Jury time is over. So yeah, thank you. Big applause. And now the next team, team number 5, friend of an analyst. Yes.
Good afternoon. I'm Ilse, and I'm part of a team that made Friend of an Analyst. That's an AI-powered real-time fact-checking for YouTube. So you would ask, why YouTube? Because based on a 2024 analytics, 45 minutes per person watches YouTube every day. Every day, 1 billion hours are watched on YouTube, and more than 500 hours are uploaded every minute. So YouTube is one of the biggest video platforms, I would say the biggest at this moment, and it has become a major channel for disinformation and manipulation as well, because it's so big. And audiences heavily nowadays rely on the video, so they rely on the information that we can achieve from YouTube. And impact is really real, because the one video that you post on a YouTube can be shared thousands and millions of times in really short period of time. So we are providing solution. An AI-driven tool that automatically ingests YouTube videos, including live streams, analytic audio, and visual and text content. It identifies asserted claims with timestamps clusters related claims across videos. And it cross-references trusted databases and open sources to produce ranked list of supporting or refuting evidence. So can I please ask a demo? So yeah, we have made as a prototype Google Chrome extension that is fact-checking this video and giving extra information when the information is asked from the user side. We made this idea from scratch. When we came here, we had only the idea what we might do, and we came together Friday evening, people who don't know each other at all, and this is how far we have got. Thank you. So why we believe it's gonna be, the companies might be interested in it, because the global fact-checking and verification industry is actively shifting to AI for scaling, and governments and defense agencies are prioritizing disinformation detection as a part of hybrid threat and information operation strategies. And the third thing, within the Europe, there are substantial and growing public funding programs as well that are targeting this misinformation or disinformation. So yeah, the market opportunity that we can see is the total assessed market might be all organizations needing a video level trust. This serviceable available market might be more focused on the NATO and EU public sector or NGOs, but the serviceable obtainable market might be the ministries of defense in EU or NATO countries that we can see up to 10 large newsrooms or NGOs. The business model that we are thinking about are subscription and licensing, the enterprise commercial licensing, professional services and integration, and grant and consortium funding. So, do we have competitors? Of course we have competitors, but the thing that we are trying to achieve, we are trying to put together combine all the features that are in different tools already, but combine them in the one tool that can help with the video detection of false news. So the future steps, here you can see detailed information. Our end state, as we think, might be in 3 years. So this is our team. We're a small team of 3 people, 2 technical people, and me as a product lead. And investment funding is that we're asking this amount of money to product the real prototype and to give it for organizations to test. And this is it. Thank you.
Big thanks. And now the jury questions.
Thank you. You showed the roadmap, but can you please elaborate what are your next steps regarding this solution?
Then I'm going to ask my colleague that's technical guy.
All right, so we can go so many ways and we can extend it so much further. So first of all, we can cooperate, for example, with governments and gain more trustable and focused information sources. Right now, we had our own free data sources we found, and so that's great. We can focus on more in-depth technology. We can focus on so many different aspects of the technology. We can perform analysis of the video. So what is the agenda, for example? There are dozens of aspects. It could be even years of development to be like, okay, Now we can protect against every aspect. We can get in-depth analysis, and we can figure out what is the video's purpose. Is it AI generated? What they are trying to do? Yeah.
I have another question. So you are asking quite a lot of money. Comparing to previous teams, the previous ones said that they need just 100, 200,000 euros. You are asking for 750,000 euros. And you are just dealing with the AI, which is like open access tool. And so my question again would be, are you sure that your first and primary end users will be directly ministries and governments? And I don't know, why should government trust to your new product? What's so unique in it?
First of all, we are asking actually small money. They just don't know yet how much the product costs. But AI is right now very actual industry. It's a multi-trillion industry even. Everyone's investing and they are generating more and more content into AI, and we need to analyze and fight against disinformation against AI by investing our money to identify things that are incorrect, things that are not great, and realize, okay, this is our approach. And regarding money, right now there are also a lot of grants and funding programs to assist us. So it's just a startup capital, and it's normal to have it for AI industry especially.
Okay, time's up. Big thanks to this team. Okay, and now team number 7 with the idea simple.
Our first slide is missing. Wait, sorry.
This is your first slide?
Okay, yeah, now it's correct. Right. Dear judges, ladies and gentlemen, I represent Team Simple, and our aim is to simplify war no matter how complicated it might be. Although complication, I personally believe that is an understatement when it comes to describing the war situation. The next slide does contain graphic imagery, so be advised. In reality, war is hell. War is bloodshed. I myself am from a war-torn country, and I got to see the experiences of my relatives and as to how they've reacted to war. One of the issues that I experienced in my own country is that there weren't enough specialists present in the situation to answer the needs of the battlefield. As we continue to digitalize in the battlefield, we need more specialists. So what we are thinking of doing is introducing an element into a pre-existing software known as TAC, short for the Team Awareness Kit, as in a way of allowing the privates, the foot soldiers, the riflemen to access crucial information and to have it as, well, to ease access for it, basically. Our solution is to introduce a large language model plugin for the Team Awareness Kit for the purpose of answering the specific needs of soldiers and for select scenarios where, for example, a specialist might just be out of reach. One example that we have come up with is, for example, you're in a situation in which you need to set up a Wi-Fi bridge and you are not, you're not prepared to do that. You're a private, a foot soldier. You don't have technical experience. You can ask this from our LLM as displayed in the demo image as you see on the slide, that you can ask it and it's going to give you step-by-step instructions. It is a local LLM. It does not depend on any servers or cloud and such. And it's going to be programmed off of manuals. What we are suggesting this LLM is we want it to be a replacement for lengthy manuals that soldiers would then not have to go through in order to solve a certain task. Here you see a 133-page medical first aid manual. Yes, every single bit of information is important in here. But how much easier would it be if in a time of need you could ask it something specific and receive a specific response? We're not thinking of cutting them out of the equation, but we're thinking of using them to build a database. And from that database, the LLM, developed as a plugin for TAC, would then provide certain and necessary responses to foot soldiers who then might not be educated in a technical field or in a state of panic to prevent further emergencies. This is our team. I don't think there's actually much to say about our team. We're just 4 people from Azerbaijan who study at RTU. And as a team, what we ask from you, the audience, is to have trust in upcoming technologies. We don't necessarily want funding from you, but we want you to embrace innovation and change. I do understand that such technology is yet to prove itself, but the more we train it, the more we prepare it, the more prepared we will be when we will be in its need. I thank you for your attention.
And now it's time for jury questions.
So you sound quite experienced already. So my first question would be, which I couldn't find in your presentation, also in the description I have, what were you doing during Hackathon? From which point did you start it, and what's your final point now?
So our final point is that, as I demonstrated previously, we were testing a local LLM to see if it's actually suitable in order to answer questions from manuals. What we did during the LLM is we set up a local LLM, we gave it some manuals, and we asked questions off of those manuals to see if this LLM, if the response of a 3 GB file can give adequate responses, in which case a specialist wouldn't be required. We didn't have enough time to actually develop the plugin. We don't have the technical expertise yet, but we're showing this as a proof of concept that an LLM plugin for the already existing tax system would be a pleasant change. We're not trying to reinvent the wheel, we're more or so trying to improve what already exists.
Thank you. What was the computing power necessary to run the LLM? Can you do that on the phone? Do you need specific like Jetson or a computer?
Yes, we are capable of running this in our phones. For example, I personally, when I was simulating this situation, I ran it off of a computer. It's a rather low-end laptop, and I was still able to receive around 20 tokens per second in the response of the LLM. And yes, this technology is suitable for phones as well. I believe that if there is sufficient government funding, a specific LLM can be produced and developed for a mobile device. And the LLM that we were using, it did have a bunch of unnecessary information regarding our field of research. So we could achieve a faster result and a more efficient, less power-consuming LLM if we were to develop one locally by ourselves, more or so focused on manuals and its simplification.
Okay, time is up. Big thanks to this team. And now I welcome to the stage team number 8 with the idea name OdoLink. Oh, I pressed it. Oh.
Okay, hello, my name is Artis, and at OdoLink we are creating networks by linking drones. Fiber optic drones have solved the issue of jamming, but the issue is that the range is limited. How do we get past the limit of the spool? How do we communicate past the spool? The solution? Simple. Merge the cables together. Have these optic fiber drones and chain them together. That is our solution. Essentially, a fiber optic drone flies to a spot, it lands and acts as a relay station. It's connected to the base by an optic fiber. The next drone flies to the relay station, blind, by dead reckoning, and then by radio communications connects to the relay station. Then they connect the ports, connect the optic fiber cables, and then the drone can either fly further, to act as another relay station, or to go out and whack something. So essentially a snake behind enemy lines, this whole idea. But the solution, why not missiles? They can go further, can hit heavier. It's quite simple. They are cheaper. The drones are very cheap. And by having these optical cables, we have larger control for the drones, because missiles heading at a huge speed when we can control the drones. Also, this idea of optic drone chaining also has application in the civilian side for disaster relief. For example, in hurricanes or other places where the telecommunications have been destroyed, we can essentially set up 100 kilometers of optic fiber in 100 minutes. Essentially, as fast as the drone can fly and merge, they can create these communication links. So the linchpin of this whole idea of this optic fiber drone chain is our product. It's our connection ports. It's how we connect the drones together. Our idea is the drone flies to the relay station. There, essentially, it docks, it plugs in its cable, and then the relay station fixes it in place. Here are some of our designs made in AutoCAD by our technical team, and we plan to use MikroTik ports. Essentially, our business model is developing these connection ports. The development cost will be high initially, but we plan to have big enough margins to include the know-how, the support, to add these modules to these drones to be able to basically create these chains. Our expected market, this is one example. Another example which could be hired, for example, 2,000 drones outfitted for 500 euros would mean 1 million euros per month. So, yeah, our team, we are 3 students, 1 business person from the Stockholm School of Economics in Riga, and 2 electric engineers from the Riga Technical University. And we spent sleepless nights to bring this idea to you. So what we're asking from you, 50K. It's so we can create relationships with people and create a physical prototype. Yep. AutoLink, create linking drones into networks. And if there's one thing you have to remember, optic fiber drone chains. Thank you.
Jury questions start now.
I already have a question. So you're asking 50,000 for just building the relationship. What are you going to do with that?
It's essentially we need these relationships to test out the prototype.
Relationships between the organizations, or what kind of relationships?
Just working relationships like know-how, for example, testing.
So you need the money to go and speak with the government or LMT or whatever other industries?
We need the money for the prototype, and in part we are developing the prototype and the relationship.
What was I asking?
Okay.
Thank you. Are there any similar solutions with these optic cables you mentioned already in the market?
Well, the idea of the... Okay.
Yeah, hello. So when we were doing the research, there have been some studies that have been made, mainly in America, for disaster relief. Essentially, a flying cow from AT&T. They added optical cables, used the drone as a tether to kind of make a 5G network, in a sense. Our idea is a bit different because we're not using the drone itself as like a antenna. We are using multiple chained drones to have fiber optic communications between essentially bases, right? So we have 1 gigabit speeds, essentially of internet, so for disaster relief. So there's been precedent in a different way. The way we present, we haven't found. Yeah. Additionally, one of the disaster relief scenarios is using them to kind of scout areas as well. So from a large distance, you can also do that. Yeah.
So, okay, let's say nowadays the drones can travel up to, I think, even 50 to 60 kilometers with optic fiber cable. So where is the value in that? Let's say if you use the chaining.
So essentially, the value in that is that you can go further than 50 kilometers. You can have essentially set up connections from Riga to Liepāja with 4 drones, 5 drones, essentially. That's the main idea.
Okay, awesome. Big thanks to Odolink. And now I welcome the next team, team number 9 with messaging systems Sprīdītis. Okay.
It was quite loud, wasn't it? If I had previously told you that I will begin my presentation after the whistle, it would also convey a message that way. And that's how whistles have been used previously for a very, very long time, both in civilian sector and also in military sector, right, to convey a short signal message. We are here to work on that idea and to improve it. What problem are we experiencing right now? So on the front lines, there's often times when the people there, the soldiers, are not able to send a message to their teammates to some other places because they would either that way expose their position, making themselves very vulnerable, or they are experiencing radio jamming, or sometimes the most simple things, dead batteries, which make it impossible to send a message. Currently, the way that people are communicating on the front lines, mostly it's through radio comms, sometimes also visual signals, but in the more previously mentioned optical cables and other types of cables, and in the most dire situations, and at least historically, also messenger people, so-called runners, people who would actively go themselves to deliver some message. But all of those have some problems. They can either, well, previously mentioned radio jamming, they can either experience radio jamming, they can be detected, as with the case with radio frequencies, because they are oftentimes monitored. There's the risk of interception and, well, high energy consumption, right? And also risk of life with the case of runners. Our solution, our idea how to deal with that is to create a whistle. A whistle that would create an ultrasound. So a sound that we cannot hear ourselves by ears, and modulate it. So change frequencies, that way transmit a message. And there would be a way to see what the message was. What we've done over the course of these last 48 hours, we created 12 prototypes just for the frequencies, 2 prototypes to test different loudness levels, and we created 3 working prototypes, how we imagined the product would work itself. Right now, what I want you to see, we'll do a little demo right now. We'll do a demo right now, yeah. Davis on that corner will transmit a message using our... okay, yeah, he will transmit a message, and Gustavs will, yeah, he will receive it right there. Let's focus on Gustavs right now. And do we see a message? Let's do it again. Okay, let's... Well, as it happens with live demos, sometimes it doesn't work out. But we attached in our description a video of where it actually does work. But what we plan to do, so the next steps would be to work specifically on the design of the whistle. So right now you saw Davs held a very large box essentially. We would definitely want to make it smaller, more lightweight. And right now for demo purposes it used audible sound, but really we would change it to just ultrasound. And as a receiver end, instead of using a computer, we would change it to Android Team Awareness Kits and do some live testing, field testing. The way we imagine the business itself, it would be a business to government type of model. So our primary clients would be from the military or civilian defense. So a typical user would probably be a soldier on the front lines who would have to send short, covert messages. We imagine that the price per unit would be under 1,000 euros because the price to create one is approximately 200. We are asking for 3,000 euros for developing 15 prototypes, and we are asking for a partnership with National Armed Forces to gather operational feedback on how they see these how they see these whistles working and validate results. Our team, and in case you want to contact us, here's the information.
Okay, awesome. Now it's time for jury questions.
So your idea is to develop a whistle without a sound.
Yeah, that's...
Yeah,
well, it would not... I'm sorry, not a
going,
sound. Yeah.
I don't have a lot of time. I have only 2 minutes, so wait for my question, please. So you will use the ultrasound to not detect the place from where the sound is coming. But have you thought how does this sound will affect other alive creatures in the environment? Because the ultrasound, for example, bats, birds, insects, other alive creatures will the sound will affect them, and they will start to be active in the place. So anyway, you will say, where are you?
Yeah, but I would also like to argue that guns and explosions also would alert animals in the area. So most likely the area, the idea for the whistle wouldn't be to use it on a range of more than like 10 kilometers, right? It would be a local messaging tool to really use in these places where at times when you cannot communicate any other way.
Have you calculated the distance of the ultrasound? Because let's say in air the speed is 330 meters per second, and what's the distance that you can communicate in?
As for the distance question, I believe 2 kilometers was the answer that we checked beforehand, that we could, like, with the idea that we have currently, it would be feasible on a straight line, transmit the sound over 2 kilometers.
And in the forest, in
yeah,
difficult terrain?
Obviously, the distance would be shorter. What we've tested currently with our bare bones prototype is a distance of, I believe it was 200 meters. 200 meters. That's a distance that we are currently, with our prototype made in 48 hours, we are comfortable with. Just now, some technical issue, but yeah.
Okay, so that's it. Big thanks to this team. Applause. Okay, now I welcome to the stage next team, team number 12, Local Next.
Okay. All right. I think this goes forward. Yeah, that one goes backward. Okay. Hopefully I'm ready. Hopefully you guys are ready. It's nice to see you, Churi. And my teammate, once we get to the slide where there's going to be the prototype, he's going to come to you with a prototype to show how it actually works. Because we got 2 parts of the prototype, and once we get there, you'll know. So, communication is key. It's the key part of a relationship, right? And it's also key in war situations. So once you're on the battlefield, it's important for you to relay information. Right now, what our team focused on was autonomous drones. Autonomous drones try to fly out, gather information, get it back, and that information is later on being used by tacticians and other people. Now, what is the current problem with autonomous drones? Is that once they fly into jamming range, usually they just drop out of the sky, right? They lose their signal, and it's difficult to work with them. And we tried to tackle that solution. We started with trying to figure out what would be a good antenna, if there is a possibility to filter any type of radio waves. We went to mesh networks, which I'm going to explain to you why we decided to leave them. And later on, we came up with our beacon-based solution. The beacon-based solution is going to be in two parts. It's going to have a modulated carrier, which is going to send out signal, which is going to be encrypted so that we know which beacon is ours, which beacon is the fake beacon, so that the drone with a phase direction array which is going to turn around 30 times per second, is going to be able to figure out with an algorithm which are the best beacons for the drone to use to go throughout the setup path, which is basically going to be the setup before. And the idea for these beacons is that they're going to be easy to drop, easy to deploy for the military to be able to put them into strategic positions. And so we go with the demo of our product, which is with our beacon, basically. So what we're trying to show the judges right now is how it can right now detect the distance, and our complete product would be more so focused on positioning, because we're not a GNSS replacement, we're a GNSS assistant. In places where GNSS doesn't work, we want a rapidly deployable solution. And that is our idea, is to give positioning to autonomous drones in places where they can't get it. And what I wanted to clarify, because we saw a lot of other solutions that were using mesh networks. We also thought of that idea. It was wonderful until we talked to experts, and experts pretty much opened our eyes to the thing that it is impossible for you to send out and communicate with other beacons horizontally because of difficult terrain and other problems. Now, our use case is, as I said, we're a GNSS edition. So what we are is basically a location provider for autonomous drones, and we're really scalable. So we're not really competing in that way. And the market is pretty huge. As we know, there's a lot of military spending going all around the world. Wars are still happening. There's a lot of conflict. So people are interested. The only problem is that the cost of entry gets bigger as the competition becomes more developed and everything else. Now, our team is absolutely amazing. Now, this is, by the way, this is a random team. We grouped together on Slack. We have two high schoolers who did most of the heavy lifting. We have a radio technician who's absolute genius. We have a mathematician who's won, who hasn't won, but he's got medals in mathematical Olympiads. And when I saw the Slack messages, I knew I had to connect. And we have Eriks, who's a 25-year-old modeling prodigy. And then we have me, who's right now on the stage a bit scared, not really scared, but anxious about everything that I'm saying, and is trying to do the best way to just send out the information that our team has come up with in these 48 hours. Now, what our approach is basically we have to get a government approval to start developing the normal prototypes, do some research on already existing solutions, and then we want to do advanced prototyping and field testing in together with national security forces. So yeah, that's our ask, is just to get the approval, and we are LoConX when GNSS fails.
Awesome.
I'm gonna get our cracked 16-year-old to answer the technical questions.
Okay, so yeah, now time is for jury questions.
So once again, why do you think your invention is better than other ones? Because there are so many analog systems in the world already available.
Yeah, so the problem with these systems is that, well, you need a pilot at the center of it. And oftentimes those video links take up quite a bit of bandwidth and are jammed first. And often, well, the missions that are being carried out can be autonomous. And what we're seeing is the introduction of GNSS drones and GPS-assisted piloting, where you don't have to be at the controls the whole time. But the problem with that is those drones are being jammed. The signals, the GNSS signals are being jammed. So we're going to replace those with a ground-based system, something that is very similar to the aviation industry. VORs, very omnidirectional range systems where you're beaming that signal and you're able to fly towards the node.
Okay, what's the accuracy, what you're aiming for?
Well, so it's calculated that a drone that flies 20 meters above the node, which it tries to fly lower because of the fact that that would increase accuracy. 20 meters above the node, you get a precision of about 2 to 4 meters, which is pretty good for positioning.
With that being said, because you're flying towards the node, or if you have two nodes, you're able to basically calculate the position between them. The maximum accuracy is above the node. So what matters at that point is if you actually know the original location of where the node is placed.
And how do you set the location of the node? Do you have that encrypted in the node? What kind of timing you have for the nodes? If you have.
The signals we're transmitting consist of two parts, first of all, and it's very similar to what they do in the aviation industry. So what we're doing is we have a modulated carrier, which basically has that encryption key, and we can make sure that that's our node, that we're flying to the correct nodes. As part of that, we also have the location information. But for the actual drone, we're phasing a signal. So again, this is something that the VORs do, is they have a phased antenna array. We're able to change the direction of the signal 30 times a second, and because of that, find out a bearing towards that node and fly towards it.
But the question was, how do you know the location of the node? How do you set it?
Yes. Well, when we set the nodes, we can use much more expensive, much more accurate systems like laser-guided drones and dead reckoning and laser-guided drones, which can increase the precision.
Big thank you to LocalNex. Okay, the next team is Team 13 with the idea name Celeste. Oh. Okay.
Can we start? So, hi everyone, my name is Emilia. I am a cadet at the National Defence Academy of Latvia, just like the rest of my team. And jumping straight into the problem. So, during the past few years, malicious satellite navigation interference has grown exponentially. And here you can see the data from the most affected region in Northern Europe. As you can see, Estonia, Latvia, Lithuania, and Poland. Data from 1 year ago and data from the beginning of the year. The situation has gotten so bad that 13 countries in May of this year wrote a letter to the European Council to ask for a solution. So, and the solution, one of the solutions that the European Union Council came up with, which is the one we are focusing on, is to reassess the current reliance on satellite-based navigation, because right now most of the systems are reliant on satellites, and therefore when the satellites are jammed or spoofed, both military and civil operations can be significantly affected and even endanger lives. So the code word, the code phrase that we focused on is developing complementary systems. So we propose to you Celeste. We reimagined the oldest navigation method that we could think of, celestial navigation. So what are the features of our solution? So first of all, this would eliminate the need for satellite data. In some instances, for example, when the satellite data disappears, the system could kick in and calculate the position and navigate the aircraft. We are focusing more specifically on aircraft, on UAVs, and this as I said, this would not be a standalone system. It would be a backup or a complementary system for other current positioning systems like the inertial navigation system. So it would just improve the accuracy, and it is incredibly relevant when it comes to long distances. Accuracy, well, INS alone cannot provide 100% accuracy. So our product, we plan to create an automated celestial navigation module. You can see it here as well, the idea for it. Our goal is to make it as simple to use as possible. You just plug it in and play. Of course, there is also a close-up. So it consists of a camera, a low-light camera that detects celestial bodies like stars and planets, for example. And the computer inside of the product calculates the zenith angle of these select stars to the North Star and the overall attitude of the aircraft. And so it can give you precise positioning information. It sounds difficult, I know. And this is our hackathon journey. So at first, we came here, we had an idea. First question, is this a crazy idea? It did seem crazy to us, and I bet it seems crazy to some of you. So these are the other questions that we tried to answer. And our entire work during this hackathon was more research-based to answer these big questions. Like, is it even possible? What is the point of it? Why? And can we even make it compact? And can we justify it? And during long hours of research and not sleeping, we answered. We believe in it. It can be done. So the market opportunities, you can add it to a bunch of UAVs. You can use it in maritime industries. And the biggest challenge for us would be to integrate it with various systems. But we believe these challenges can be overcome. But it is lightweight. We believe we can offer low cost. And our future steps would be the biggest ones to join forces with other people, other enthusiasts, and to get funding from the Ministry of Defense and the European Defense Fund. So this is our team. All 4 of us are Air Force cadets in the National Defense Academy. These are our roles. And tonight, when you look at the night sky, look at the stars and imagine the possibilities that are right in front of you. Thank you.
Awesome. Now it's time for jury questions.
My question is, what is the precision that you plan to achieve?
Well, with our calculations, we believe that together with the inertial navigation system, over long distances, we can achieve the precision of at least, well, the precision could be less than 500 meters, if I believe so correctly, right? Maybe even smaller. We will still have to research it. There's a lot to calculate, but we do know, and we can surely say that the precision with this system, if we implement this system with the inertial navigation system, it will be much more precise than the inertial navigation system alone.
Thank you.
You mentioned in your presentation that this is a low-cost solution. So did you calculate how much does it cost?
We did calculate it. We did calculate the hardware. So the hardware right now in our calculations can be less than 200 euros, maybe even smaller. But of course, we will still have to determine the price of the software and the software development.
Have you thought of any specific use case? Let's say why I should choose 200 euro solution instead of, let's say, 5,000 euros precise INS solution with the directing time for, let's say, 2 hours?
So our most discussed use case was in stealth drones. So a stealth UAV, which there is no communication for it allowed with other systems because then it can be detected. So a stealth UAV that is operating in high altitude beyond enemy lines, and in the case of the inertial navigation system maybe failing or not being as accurate, this could be a good backup in that case exactly. But also we believe that there's a lot of potential in maritime drones and maritime industry as well. Thank you.
Okay, yeah, the jury time's over. Big thanks to Celeste. Okay, the next team. Team number 15 with the team idea name Branch Line.
Imagine this. A group of soldiers have just pushed the front line forwards. Exhausted and injured, they are in need of supplies. When GNSS and networks get jammed, resupply lines can get slow, inaccurate, and even dangerous. When troops push forward, access to supply routes are often cut off or damaged. And as a result, troops are left without food and ammunition, the things they need to survive. When a unit secures a new area, they need supplies now, not in hours. Our mesh system is air-dropped, and it forms a local positioning system in minutes. A resupply robot can come later and get the supplies where they need to be, when they need to be, within the mesh system. It is fast, accurate, low profile, and tough resupply for the front line. Here's how it works. We have a demo. Can we please get it? Can the yeah, here it is. So a drone flies over a large area, and it drops beacons or nodes that anchor themselves to create the positional network. It is precise navigation for unmanned vehicles, and it is also self-healing. If one of the nodes gets damaged, as you can see, the network forms back and adapts to the situation. So, about us and what we did. This was our first hackathon ever. And so the first thing we did was basically slap many ideas against the wall and see what sticks. And after that, we found an idea we are willing to work on, and started with, of course, research, consulting real military personnel. We made demos and prototypes that are getting shown to the judges, and if you're interested, you can, of course, look at them later. And we took advice from experts, made the simulations, demos, presentation, and so on. How does our product differ and why it's better? A lot of similar products are being used indoors, and in comparison, ours is low cost. It is also made primarily for military use and is completely autonomous. About us, we are a team of high school students, and we are obviously very ambitious, and we are trying to sort of modernize military industry with our new ideas that are built from scratch. And in the future, what we would need to do is to realize our MVP. For that, we would need around 5 to 10K, depends, and we would need to deploy a field test, after which we could seek partnerships and sponsors to develop this idea further. And in the future, it could be integrated with mobile apps and other types of supply UAVs. And long-term, it could be a fully autonomous swarm deployment, self-sustaining system. Yeah, our system can save lives by keeping people connected when other networks fail. Thank you. Questions?
Jury time starts now.
What are you planning to do with the money if you win?
We would like to develop the project because, as you have been shown, we only had 2 signal making objects. We would like to expand more and get more and try to at first just throw them out in a grid and test the triangulation systems, and also develop further the parachute systems that the drone would deploy, because the idea is that these boxes that contain the transponders get stuck in trees, expanding their line of sight without us needing to do practically anything. They position themselves and they create the grid, and we would like to really work on the idea and start to make more practical prototypes that are not just simulations.
If you don't have any GNSS, how do you know where you put the node?
Basically, this is a quick short-range solution. We know approximately where we have people, and we throw the system on there. And that is a system, and what's in the system knows where it is in the system. We do not need to know the precise geolocation of the object, because it knows where it is relative to the system. So if you put the robot in the system, it will find the soldier or group of soldiers who have the anchor node that's sending the distress signal, and it knows how to get from where it is to where the soldiers are.
Thanks.
I believe you will not be able to respond quickly to my question, but maybe that's the thought, because you said that this product is for the new territories where no one else have been there before. So I cannot connect your product with the idea, because if you're saying that you want to deliver the food for the new territories, you don't know the dangers in them. So how would you solve that?
Really quickly, we have, for example, when wars are going on, territories are regained, and when it is pushed back, when we push people back, there are soldiers there right now, and they have used their equipment getting over there, getting in. And that's where we throw out the mesh so we can quickly resupply them with the needed essentials, food, ammunition, water, and that. We are not planning on making long-range routes to supply.
Okay, thanks. Awesome. Yeah. Again, thank you to Branchline, and now Team 16 with the idea Hop. Hop team, yes.
Thank you. Good afternoon, ladies and gentlemen. Today we're gonna talk about robots. Well, not these robots, but this one. Unmanned ground vehicles, which can be used for multiple purposes, both for logistics, or you can put an RPG on it. But the most valuable part to use an UGV is for the rescue missions to save soldiers within the kill zone, if you know what kill zone is. So, but we are here to solve the problems. So what is the biggest challenge of UGVs? Well, as one Ukrainian soldier says, communications. Why? Firstly, because you cannot use, nowadays very popular, optical cables in UGVs, because they are very vulnerable and can be hit by enemies, FPVs, for example. Secondly, due to the fact that the drone is very close to the ground, a landscape and other surroundings just weakens the radio waves. And finally, our enemy also has jamming solutions. So here we are, Hub, and we made radio communications modules, especially for UGVs. Well, how it works. When I say module, I mean, yes, exactly, module. Let's take a look inside the module. Well, the idea behind this is, of course, hopping, which is changing between different channels and frequencies. So when one channel is jammed, you can quickly move to another, and in such a way, you move between channels faster than the enemy jams them. But, well, in this beautiful drawing, you see that we have 3 modules. Well, this is for the reason that we need a complete mesh. Why does this? to operate the drone, because we need the same models in the operator, on the ground vehicle, and of course on the relay, because as I mentioned, we have landscape, we need to combat this problem. So basically, the next question is, well, why our UGVs need this? And the answer is that nowadays we have a lot of little and also successful UGVs manufacturers, and kind of none of them develops their own communication solutions, because all the people wants to buy real one that are effective and ready to implement. So in such a way, when offering to the market, well, affordable but effective solution, we can allow for more beginner developers to be competitive at the market and to grow the market, of course, to the positive direction. And well, let's take a look also at other alternatives, because why I say it's affordable, because if we look at the price, it's 3,000 for 3 modules, which means like one module for 1,000. And of course, we're not going to beat Silvus, which is of course dominant here, but at least we are getting balance between quality and price. But of course, cost effectiveness is kind of not enough. Therefore, we introduce our key feature, which is open source. So we allow our operators who develop the drones and combat solutions to modify both hardware and software. So they can put different antennas on the drone with a different polarization and wave curve. And of course, they can also they can modify the channels they're using and the hopping mechanism. Well, at the market, well, let's just the numbers speak for themselves. It is calculated if, well, at least 15% of the price of a one UGV is used for communication systems. And, well, as we can see, the market does not stay in the one place all the time. And in our team, for me, it's a pleasure to be involved in that, so we can bring together real huge life experience and also a little bit of enthusiasm. And well, I think in such a way, new solutions can be implemented and created. So the whole idea was born in the hackathon. Well, also all the technical visualization and plannings. But of course, we plan to build a legit MVP in some time. And of course, you see we need a little bit of money for that. And in the future, of course, at the end, in about 2 years, we are planning to start the business development. And my final statement is about that. It's about the war of drones. I think, and I strongly believe that it is not a war of drones. It is a war of people who develop and operate the drones. So it's a call for action for you guys. Just look around and search for people you can do some crazy epic shit with. Thank you.
Okay, now start time for jury.
How did you calculate the price for this solution? 3,000?
How did we calculate? So our friend Maris, we had a slide where we had all the components. So we just had the price of all the components, and that's how we calculated the price. And of course, we put a little bit more, so for some unexpected costs.
So if I understood correctly, that your idea is to make a solution which you can add to different kind of commercially produced drones or whatever.
Exactly. We are selling this product to the manufacturers of UGVs. So they just, they can produce a great, well, vehicle itself, but if they do not have a great communication system, well, it's trash, you know. Therefore, if we can create something that is more affordable and is not only a civil blocks, there was also in the one slide, which is quite limited in range, and all others in the first column. So we can just create much more compatible drones on the market.
The idea is to use relaying, or it is direct connection between the control station and the drone?
Relay for video signal, because well, how it's English? Because to operate the drone like vroom, to not to move it, you do not need a relay, because you're using another base which is lower frequencies, so there is kind of no problem with that. But if you want to specifically achieve to see a video signal from a drone, and it's crucial, for example, for mining, demining, and other tasks, then of course you must use the drone as a relay. Nowadays, well, there is not a single other solution to somehow transmit this radio waves for a visual signal without the relay.
Okay, and quick question, what's the distance, what do you expect?
Well,
one number, simple number.
Well, of course, 20 kilometers is like our the mark we are tending to achieve.
Okay, thank you.
Thank you.
Okay, again, big thanks to the team Hop. We are nearing the end. We have 2 teams left. So I welcome to the stage Team 18, RF Dream.
Hello, we are RF Dreams, and so we are solving the challenge number 2. Sorry, how to... Yeah, sorry. Thank you. So this is our team. We are just quite amateurs, mostly from computer science and economics background. And here is our problem. Imagine a scenario when there is invasion to Latvia. We are most likely losing some of the territories. So we are sending drones to attack some enemy positions. Enemy GPS spoofing works because it's easy. Latvia is small. You can deploy GPS spoofing systems in not a big amount, and it will work efficiently. So our drones don't reach the target. We lose it somewhere in the forest. So we need basically a totally new defense doctrine. Here is the idea. Your drone is a boat, for example, and GPS spoofing is a fog. To orient in a fog, ship needs a lighthouse. If we have many lighthouses, we have much more vision and understanding where we are. So, well, ladies and gentlemen, welcome to the Operation Lighthouse. A system of distributed beacons, around 5 to 10,000, is spread across Latvia, and when enemy GPS spoofing works, drone sends signal and lighthouse activate. When it's turned on from a sleep mode, it sends back 2 pieces of data. Its location and location to other neighbor beacons. So basically, drones detect spoofing by comparing their own coordinates with lighthouses and autonomously navigate through some random node generated from neighbor ones. So more lighthouses, more roads, better efficiency. But still, we are able to lose up to 40% of beacons and still be able to navigate through our homeland airspace. So this is basically the idea how they are distributed. Overall, it's around 3 beacons per 5 kilometers per square. So, as I mentioned, it works in sleep mode. So the guaranteed time of its work around 5 years, with in-warp mode in around 1.5 years. And how are we actually going to compete with such big companies like Lockheed, Northrop, because they are taking over the market now. However, our solution is disposable. So while many are focusing on something really niche for special operations, which is, of course, tech savvy and very costly, we are something really disposable, mesh resilient, mass deployable. You just place it and it works. So we are taking over an untapped segment of GPS denied navigation market. This is approximate cost. On average, it's around $75. With bulking, we can diminish it to minimum around 60. So cost of 100 lighthouse minus logistic, minus infrastructure, minus labor, around 10,000, and we can cover 164 kilometers. Or just like a really small amount, actually. And that's basically our timeline. Firstly, we finish with prototyping, then we consulting with Ukrainian and Latvian ministry organizations, testing, negotiate with municipal authorities to receive allowance to deploy our beacons, and search for supply, do assembly lines, and finally produce first 100 of lighthouses. Here you can find the simulation and technical presentation with much more details. And thank you.
Okay, jury time starts now.
Okay, what's the difference between the two other solutions presented today?
Good. So our solution is deployable in a peacetime and could serve as an orient as for commercial drones, and also for in the military time when, as I said, we are not reachable to the occupied zone of our homeland, and this is the only possible alternative in the environment of GPS and radio electronic warfare spoofing.
And you use radio frequencies, right, for the communication?
Yes, we are using 950 megahertz, which is a bit higher frequency than it's used for communication between drones. So we will need to deploy extra antenna on the drone to do this wake signal on the beam and to receive it back with coordinates and next beacons.
So basically, if I understood correctly, you want to make small boxes and distribute them all around territory.
Absolutely.
So what would be the distance between the boxes so that they work? Or have you calculated how many boxes would you need to distribute around the Latvia territory?
Yeah, so I mentioned around 5 to 10,000. It depends on the proximity to the border. And like, of course, closer to the border, the distribution of them will be much bigger. We don't calculate it yet their targeted location. Like, we only know like approximate density around 3 beacons per 5 kilometer square. But we plan to do it on the stage of field testing. So actually assessing the efficiency when we can allow ourselves to lose one beacon or several beacons and like still continue working. And then of course just using Lagrange optimization problem to minimize the cost of deploying these systems.
Also, what you have to think about, how would these boxes work in a different environment, like forest or cities?
Yeah, we will make sure that the box is protected from water and like weather conditions. And basically, it will be fully packed. And so it's not possible to do any modifications to it. It's really like one-time use. But like you put batteries there, it will work 5 years. Then it's like not suitable anymore. We are just removing, placing another. So that's why like cheap and such a low cost is really important for us.
Thank you. Okay, big applause to RF Dream. Okay, now we have reached the critical point of the last presentation. So, I welcome to this stage Team 19, Safe Path. Okay.
Sorry. Yes. Hello, everyone. First of all, good afternoon. Oh, good evening. Sorry. So we are Team 19. We're all mostly developers. So we've developed Safe Path, kind of a dashboard with navigations. This is for also civilians and military personnels. So for fragmented crisis mobility and communications, so network outages, hidden threats, mismanagement, those are optionals that will obviously happen in crisis. And for these, a unified dashboard for real-time crisis response. This is the dashboard you will see, the military personnel will see in their systems, and that's how they're gonna make operations. So you have their direct resources, safety and security with complete situational awareness. You have everything, information that you need to take or act according to the given, situation. And for that, there is a 5-step secure resource protocol. Mind that this 5 secure protocol, it is done by military personnel. So it is just like steps. They can have their own methods of doing it. So first is detection and joining, aerial assessment, stealth entry, civilian attraction, and mission closeout. So for that, this is the demo we developed in 2 days. Above you see the dashboard. That is, as I said, for military applicants. And the second one is for real time, for civilians. We've developed those zones where you could add details and also the route from point A to any points you would like. And in between, you could see the shortest path it had to go was from the Achman's breeze, right? But it went other to the near to the Swedbank breeze, because obviously due to of the yellow zone that they have in the middle. And you could see below there are details like which way to go and all that. So initial alert and asset development, survivor locations, clear and cycle, metrics updates. These are the things that we're going to provide in the dashboard. And the last thing is that these two are going to, the last map will be like integrating in the dashboard. And the dashboard is mostly for military personnel, but for civilians, it's going to get switched. Obviously, they're not going to have every information. Otherwise, it's not secure. And core features of the system is data tracking, asset intelligence, operation metrics. So by data tracking, we take it like last possible IP address of communication devices and deploy some other third-party devices into the places. Also, we're planning on having proxies of shelters so that they don't attack on those like area. Security and safety by design. So security commitments, privacy first, root protection, and responder safety is drone first clearance and transparencies. So market opportunities. So there is SAM, SOMs, which Okay. And the total TAM is of $577 billion market. So competitor comparisons, we are more approachable and have more to offer. Scaling the vision, feature, and roadmap, impressive feeds, AI dispatch, wider context, end-to-end linkage. Why this safe path is critical, life savings, order to chaos, and operational efficiency. Thank you. And next step. So this is my team. Roshan, Aditya, Siddharth is me, and Sanidhya. You could use the QR code for the map that we've just developed. Thank you.
And now it's time for the jury questions.
Okay, thank you guys. What you did during the hackathon?
So hackathon, we developed this the CVAR mathematical model we implemented in the map, so to give a better route planning for any users and avoid any kind of danger zones.
And in general, like what you are providing is some kind of command and control system, right?
Yes, and also similar example, there is a map for civilians and military users. Military is going to give you the every information, but for military users, they're going to have extra edge, more information in their system, but because if they give everything to civilians, because there could be infiltration in the civilians as well. So suppose if they're going to point A, if that fails, they have planned to go to other points.
Okay, and what's the difference, for example, between Ukraine and Delta?
Ukraine and Delta?
Yes.
This is locally, and we have only thought of doing in Latvia, and it's going to be for local reason, and also we plan on implementing mobile networks in between. So that's about it for now.
Okay, thank you.
Okay, awesome. Again, another round of applause. You survived the pitches. Okay, but now I will, where do I press this? Is there a presentation? Public voting? No. Jury evaluation. Oh, I skipped that. Okay, now I will invite jury to come with me to deliberate. You will have 20 minutes now. Don't leave this room yet, but there's going to be 20 minutes break so we can decide who won and what are the best pitches. So I will now give word to Lena. Yes.
All right. While the jury goes with Martins, we have a small task for all of you participants within these 20 minutes. So first thing, please go and vote for your favorite team. It can be any of the teams of 20. It doesn't have to be the ones who were just pitching. And you can decide each on your own what is your criteria that you're judging the teams on. Each one of you can vote for your favorite team. It doesn't have to be like as within a team voting for just one other team. It can be you as an individual voting for a team. We just posted it on Slack, so you can find the information of how to vote. It's very easy. You just go on DevPost, choose the team that you want to vote on, and when you choose that team and open their team submission, you can press on the right side on the button, vote for this project. All right, so that's one of the first tasks. So please go to DevPost, take a look at all the submissions, choose your favorite team, take a look at Slack if you don't know how to do it, and choose your favorite team. The next thing that we also want you to do is we kindly ask you to fill in the feedback form. It is also posted in Slack. We really want to hear your opinion of how you did during the hackathon, what you liked, what you didn't like. It has a lot of just a multiple choice questions about the various things that you experience, the food, the organizers, the mentors, and so on. So we really want to hear your feedback about each and one of these things so that the next time we can learn from these experiences and understand better how we can improve these events for you. And maybe that's a point where you can share something that you haven't shared before with us. Any good things, any bad things, all are good and all are important for us to know. So during these 20 minutes, you have a break. You can stay right here, or you can leave for a bit. Be back here in 20 minutes, right on the spot. We'll put a message out in Slack when the time comes as well. But just to make sure that you note, 20 minutes short break. Meanwhile, please make sure you fill in the feedback form. Please make sure you vote for your favorite team. All right, so let's go on a small break. Hello, everyone. If anyone else is still out there, I posted on Slack that please come back. Those of you who are not here, please come back. Please come back and welcome to the winners announcements. So, I'm going to invite to the stage our jury representatives to say a couple of words of the winners that they decided upon. They deliberated for 20 minutes and have decided on the top 3 places. So Gunita will be the representative of the jury, saying a couple of words and announcing the winners.
So actually the whole jury has something to say, not only me. Once again, I would like to say thank you all for participating, and somehow I envy all of you. You know why? Because you had this great opportunity to participate in this event, and I envy you also because you actually choose to participate in this event. So congratulations once again to all of you, and you all had a great job within these 3 days you spent here. The other jury, do you want to say something more?
Hello, everyone. Yes, me myself, I started in a hackathon too, some like 4 years ago, and now I have a company and we are doing something. So I know quite well how it is being at your side, and all of you did a good job by challenging yourself, coming here. So that's a good thing. What you should work on the next times is think about the delivery, how you sell yourself, because good technology is one thing, and selling your technology is the other thing. So, yes, try to sell, try to improve the pitch. Of course, for our teams, lesser text in the pitch. That's a quick advice. And from my side, I would like to see that you continue in the defense segment, because we need submerged needs, origin needs, all the defense companies need a smart mind in the field. So, thank you. Yes.
Okay, can I announce the winners? Is it my turn? Great. But before I do that, I know you're stressed now and you wait for the results, so what I will do, I will take the time longer so that you can stress a bit more. Before I announce the 3rd place, I would also highlight 3 more teams, which unfortunately was in the places below the 3rd one, but these 3 teams also was very good, and as my colleague already mentioned, you have to work a bit more, and I can guarantee that these 3 teams in the next hackathons will receive their awards even for the 1st places, and those are the team Simple, the team Locanax, and Branchline. So also congratulate all of these 3 teams. And now the time of the truth. So which of the ones, which of the teams received the prizes? So can you guess which of the team could get the 3rd place? No, but I know the answer already. And the 3rd place, the prize of 500 euros goes to Autolink. Come and receive your prize. Come on. Congratulations. Congratulations, congratulations, congratulations. Smile to cameras.
Great many thanks for the opportunity to start in this hackathon. It's an amazing experience. It's stress and really the ideas and actually starting something. Thank you.
But remember, you still need to work on something because you didn't receive the 2nd or the 1st place. So please keep working because you have a good start. So don't stay there. And then the 2nd place, we had a discussions with this team. How could this team's invention affect the environment? So can you guess? I don't know how to make that sound they did, but 3D this. Set. Congratulations. Spend the money well. You make the whistle without the sound. This is yours. Do you want to say something?
Yes, Michael.
Oh no, not now, not in the microphone.
Not right now. Well, thank you everyone for understanding regarding our technical difficulties and for this amazing opportunity.
Yeah, we hope to be able to finish our project and indeed develop it so that it can reach the potential that we outlined here. Thank you.
Thank you.
You do have a potential already, but you need to work on the product, so it's like we can use it in real life. And the winners of this hackathon actually is the team. The whole jury agreed that this is the team which really understands the problem. And therefore, I will not take time any longer. I know you are tired, and probably some of you already wants to go to bed finally and have a good night's sleep or afternoon sleep. So, shall I say it loud? Celeste. I hope you will not need to use your invention, but I hope it will work. Upset. Congratulations. Congratulations, Lūdzu. Congratulations. Congratulations. So, I guess I'll be the messenger.
Thank you very much. Thank you to the audience. Thank you to the jury. And thanks for everyone who believed in us. And I want to say thanks to my team as well. And I know there is a lot to work on, but thank you. And we will do our best to make this project come to life. Thank you.
Just shortly before I leave the stage, because if I have this opportunity to use the stage, then I will use it. So I would like to express again a big thank you for all of you who participated, for the jury that you did spend the Sunday afternoon at the university, not at home. I would also like to express thanks to the organizers, Katrina and you, the team, for building up this together. So you already noticed that this event was within the Student Innovation Program, which is the new grant for the students. Please use all the chances you can get from this program. There are a lot of programs, activities where you can really use and develop your ideas. And also, of course, big thanks go to the Ministry of Defence, who supported also this event. And I think that's it from me. And if ever you see that the University of Latvia can help with the development of your ideas, problems, or you just need someone to chat with, don't hesitate to contact us. Thank you.
All right, thank you so much. And one final prize will also go to the public vote, where you were just 20 minutes ago, actually now more, invited to vote for your favorite team based on your own criteria or your own feel. So just to announce the winners of the public vote, so this one goes to the team Simple. All right. Thank you to the team, the public favorite. All right. This leads us towards the end of this event of the hackathon. I know that you might also be feeling like you need some rest after these 3 long days. I think 2 long nights, definitely. So a couple of last things that we wanted to share from us. So firstly, massive thank you to the organizers, massive thank you to the University of Latvia, like Gunita said, and to the Innovation and Acceleration Center, without whom this wouldn't be possible. Also to the Innovation Student Grants that help with all of this to take place. A massive thank you to the Ministry of Defense as well. You've heard this before, but they're also helped for this to happen and also helped in supporting this thematic hackathon to take place. And I know that many of you used the mentors that they provided yesterday, and I hope they were of really good use for you with their comments and suggestions of how you can improve your ideas. And a couple of things before you go. This comes from us as organizers. Please share your contacts with other participants. Make sure you create these lasting connections in the future. Maybe you want to participate in another hackathon somewhere else. So this is a good start where you can find teammates. So use the teammates that you already had. Might be easier in the next time. Also, please clean up your space afterwards. Try to leave it as it was. It will make our lives easier, and also it helps us to respect the space that we spent all of these days here together. The last thing is please put in your badges in the carton box. This is not mandatory, but if you plan to throw it out at home, please leave the badges in here so that we can reuse them for something else and we don't just throw things out unnecessarily. If you plan to keep it for forever, you're more than likely to keep it for forever. But if you don't, please put it in the box. It's right at the registration. We have a carton box in there where you can throw them out for us. Massive thank yous we already mentioned, and one last thing that we wanted to say before you go. This is the team of Raccoons that has been organizing it. Mārtiņš and Katrina that you saw throughout these events, and all the lovely volunteers that stayed overnight with you and supported you and tried to answer all your questions and so on. And we're a youth organization. We help make these things happen in the background and do a lot of it in the background. And all of this happens because students like you participate, and you participate as volunteers. So if any of you are interested in joining us as volunteers, helping events like these in the future to happen, or hackathons like these, or workshops like these in the future to happen, please fill in the volunteer form, whatever your skill set is, whether it's communication or technical or mentoring, or you just want to get to know other people who are excited to volunteer at such events, mostly technical events, then I think it's a wonderful opportunity. Also, you get to meet these jury members and you get to meet mentors in person who might create long-lasting relationships and possibly future job opportunities as well. At least that's how it usually worked for the Raccoons team. So that's one final last thing. And other than that, thank you so much. I hope you have some rest. And thank you so much from us as organizers that you participated. You were really lovely. Thank you.